Hi students, how are you all? I hope you are all fine. So today I am discussing as per your request NCERT example 2.5. Look at the question please. Determine the electrostatic potential energy of a system consisting of two charges 7 microcoulomb and minus 2 microcoulomb. In the bracket you can see and with no external field. Placed at minus 9 centimeter, 0, 0 and 9 centimeter, 0, 0 respectively. This is a question I hope you can see on the board. Now the question comes, how can we solve a question in physics? When you see a question, what is the procedure you have to adopt to solve a question? When you just see a question, you may go for this and this formula. That's not the way you have to approach a problem. When you get a question, make sure that you understand the situation of the question well. Understand the situation of the question. What is the situation given? You are given two charges. Okay, let us highlight the various points in this question. This is 7 microcoulomb, one charge. This is minus 2 microcoulomb, another charge. They are placed at, where is the location of 7 microcoulomb? Okay, I will now draw the figure to represent this. This is 7 microcoulomb. And it is placed with at the coordinates minus 9, 0, 0, all are in centimeters. Then where is the location of the other charge, which is minus 2 microcoulomb? That is located here. Minus 2 microcoulomb. And the coordinates of minus 2 microcoulomb are, you can see on the board. It is 9 centimeter, 0, 0. That means, where is the charges placed? If you use the coordinate frame, this is x-axis, then I got y-axis and z-axis, y-axis, z-axis, but I need not consider y and z-axis because you can see the coordinates, it is x-coordinate. Now tell me what is the separation between these two charges. Here it is minus 9, here it is plus 9, which means the charges are separated by a distance of 9. So origin is somewhere here. Origin of the coordinate system should be somewhere here only. That means the coordinate frame. So this is 9 centimeter. This is 9 centimeter. This 9 is measured in this direction. This 9 is measured in this direction. So the total separation between the two charges now becomes how much? Total separation between the two charges now becomes 18 centimeters. So now I will wipe them all. Straight away I can write the two charges are separated by a distance of 18 centimeter. Now what the idea, whole idea is clear now. This is 7 microcoulomb. This is minus 2 microcoulomb. They are separated by a distance of 18 centimeter. What is now the picture is clear to you. How can I get the answer? How can I get the answer to this question? Very simple. The problem resembles this one, right? Q1, Q2 separated by distance R. Their mutual potential energy is KQ1, Q2 divided by R. So let's substitute the values here. Mutual potential energy U is equal to, what's the value of K? K is 9 into 10 raised to 9. What is Q1 here? 7 microcoulomb, which is 7 into 10 raised to minus 6. What is Q2 here? Minus 2 into 10 raised to minus 6. Minus 2 into 10 raised to minus 6. That divided by, what is the separation between the two charges? 18 centimeter, which is 18 into 10 to the power minus 2 meter. The problem is now over. I got 9 here, I got 2 here, I got 18 here, that is cancelled. So 7 into 10 raised to this minus 6 minus 6 minus 12 plus 9 minus 3 into 10 raised to 2. This is 7 into 10 raised to minus 1. I have to say there is a minus here because the second charge is negative. 7 into 10 to the power minus 1 joule, or this answer, and the answer is 0.7 joule with a minus here. This is the initial potential energy of the system. Second part of the question. How much work is required to separate them infinitely away from each other? Work done to separate. Work done by Aaron. Work done by whom? It's a work done by the external agency. In order to separate the two charges infinitely away from each other. So it is taken to infinity from this orientation. So let me call this orientation as initial orientation. You are asked to find out the work done to take from initial orientation to infinity, right? Work done initial to infinity. This is what you are asked to find out, and we know the formula for this is U infinity minus Ui. What is the value of potential energy at infinity? They are separated to infinite distance, means the final potential energy is 0 minus, what is the initial potential energy? That is a potential energy at this configuration, this orientation. Potential energy of this orientation is what is called initial potential energy, that we calculated in the first part as minus 0.7 joule. And what is the answer we are going to get here? 0.7 joule. The work done to move the charge from this initial orientation to infinity is now getting us 0.7 joule. Suppose that the same system of charges is now placed in an external electric field, E is equal to A by R square, where A is equal to 9 into 10 raised to 5 coulomb per meter square. What would be the energy of the configuration? Okay. See, you are unable to solve this question. Means you have not identified the situation here. E is equal to A by R square. Let us just revise. What is the expression for the electric field due to a point charge? KQ by R square, right? I'm going to replace KQ. K is a constant, Q is a magnitude of the source charge. If I replace KQ with A, this equation becomes A by R square. Look, both look the same equation, right? Both look the same equation. E is equal to A by R square. In that situation, what is going to be the potential? V is equal to KQ by R. But what is KQ in our equation? It is A by R. The matter is easily done. A by R. The matter is easily done. I replace KQ with A. Problem is over. Then what is in this formula? What is R? In this formula, what is going to be R? The distance of the point from the source charge. Which means I will locate this source charge Q at the origin of the coordinate system. This is 0, 0, 0. In that situation, I will say the other one, this is 7 microcoulomb, it is located here. Then I will say minus 2 microcoulomb is located here. The coordinates of this one is minus 9, 0, 0. This is 9, 0, 0. This distance is 9 centimeter. This distance is 9 centimeter. Now tell me, now the problem becomes very simple. What is the mutual potential energy of the system? Which is, you can easily say, this is a two-particle system. This is a two-particle system. This is another two-particle system, right? This is a two-particle system. This is a two-particle system. This is another two-particle system. Okay, let us analyze this problem in such a way. This is a two-particle system. This is another two-particle system. This is a third two-particle system. Okay, now come on. So what is the mutual potential energy of this system? Mutual potential energy of this system, this is KQ into 7 microcoulomb divided by, what is the separation between them? 9 centimeter, which is 9 into 10 raised to minus 2. Plus, what is the mutual potential energy of this system? K into Q into minus 2 microcoulomb divided by 9 centimeter again, or rather I say it is 9 into 10 raised to minus 2. One mutual particle system, the other set of mutual particles, now the third set. Plus, what's the mutual potential energy of these two? K into 7 into minus 2 into 10 raised to minus 12, with your permission, divided by 18 into 10 raised to minus 2. Already what I said, KQ is equal to A. KQ in the value, and we know the value of A. What is the value of A? A is 9 into 10 to the power 5. 9 into 10 to the power 5 into 7 into 10 to the power minus 6 divided by 9 into 10 to the power minus 2. Minus. Why minus? Because this is a negative charge. Again substituting the value of KQ. What is KQ? A. And A is 9 into 10 raised to minus 5, 10 raised to 5. 9 into 10 raised to 5 into minus is already taken here. 2 into 10 raised to minus 6 divided by 9 into 10 raised to minus 2. Minus 0.7 joule that we have calculated in the first part itself. What is this going to be? This 9 and this 9 will be cancelled. This is equal to, this 2 will go up. 7 into 10 raised to 5 into 10 raised to minus 6 into 10 raised to 2. Minus this 9 and this 9 also will be cancelled. 2 into 10 raised to 5 into 10 raised to minus 6 into 10 raised to 2 minus 0.7 joule. Now calculate the answer. This is 10 raised to 5. 5 minus 6 plus 2. 5 plus 2, 7 minus 6, 1. This is 70 minus 20 minus 0.7, which is equal to 70 minus 20 is 50. 50 minus 0.7 is 49.3 joule. That's your answer. The mutual potential energy of this system is equal to 49.3 joule. This is the answer. Now what are things to look at? What is given is E is equal to A by R square. Now relating with the formula of the point charge, E is equal to KQ by R square. In this case the charge Q is placed at the origin. R is the distance of this point from the source charge. So I keep the charge Q at the origin of the coordinate system. R is the distance from this one. E is equal to KQ by R square. I say this and this equation given is A by R square. Comparing these two equations, I would say A is equal to KQ. A is equal to KQ. The value of A is given as 9 into 10 to the power 5 joule. A is equal to KQ. If this is the formula for the electric field, then the electric potential V is equal to KQ by R. But what is already Q is equal to A. So we get V is equal to A by R. In this formula, as I told you, the charge Q is located at the origin of the coordinate system. Now we get a set of 3 particle system. This is one pair of particles. A Q and 7 microcoulomb is a pair with separation 9 centimeter. Q and minus 2 microcoulomb is another pair with separation 9 centimeter. Then the third pair is 7 microcoulomb and minus 2 microcoulomb. There is interaction between these two. There is interaction between these two. There is interaction between these two because electrostatic force is the electrostatic force between the two charges is not influenced by the presence of other charges according to Coulomb's law. So there should be a mutual potential energy of this pair, and this pair. The mutual potential energy of this pair is what is calculated as kq into 7 microcoulomb divided by 9 into 10 to the power minus 2. Then you may be asking the question, sir, should I take minus 9? No. This is the in the formula V is equal to kq by r, we take only the magnitude of separation. Magnitude of the separation between the charges, that is 9 centimeter. No need to consider that minus, because in this formula we take only the magnitude of separation. So kq is A, which is 9 into 10 to the power 5. 7 microcoulomb is 7 into 10 to the power minus 6 divided by 9 centimeter, which is 9 into 10 to the power minus 2 meter. Again, the same substitution I did here, and I am getting the final answer as 49.3 joule. Hope you understood this.